Hello everybody, welcome. This is paper 1 from November 2023, time zone 1. Let's work through this and see what we can do. Alright, so far it's been, I guess all things considered for an applications interpretations question, somewhat heavy on the algebra side. Here we are on number 4 and it's still, a little heavy in terms of algebra potentially. Alright, here we go. On the following Voronoi diagram, the coordinates of 3 farmhouses are A, 03B, 83, and C, 813, where distances are measured in kilometers. Each farmhouse owns the land that is closest to it, and their boundaries are defined by the dotted lines on diagram 1. Alright. To provide water to the farms, it is decided to construct a well at the point where the boundaries meet on diagram 1. So here is diagram 1. Write down the coordinates of this point. So to provide water to the farms, decided to construct a well where the boundaries meet. So this is the boundary line here, here's another boundary line here, and this is another boundary line. Where do they meet? They meet at this point right here. The coordinates of this point, this is at 4, and we may assume it's at 8. So they're just asking for a coordinate point. It meets at 4, 8. How could we be absolutely sure that this is the case? Boundary lines occur at the midpoint between these two. So if this is a y value of 13 and this is a y value of 3 at point B, distance between here is equal to 10. That means 5 above, 5 below. This right here is going to have an x value in this case, I guess of 10, I suppose, since we're just above here, but a y value of 8. And same here, this point is going to be halfway between as well. So between 0 and 8 is going to be the value of 4. And so if we put that together, the x value of 4 and a y value of 8. But for a 1 mark question, maybe it's wrong to assume, but maybe it is sometimes actually. But for a 1 mark question, you can potentially assume that they're going to give you clean integer values and not, let's say, fractions or anything like that. That would require further kind of computation. That is to say, we're just looking for something that we can see through inspection. That is to say, just by looking. If it was anything more, it would be computation, and we could imagine a 2 mark question. Alright, find the equation of the perpendicular bisector of AC. So the equation of a perpendicular bisector of AC. Perpendicular bisector means that if we have some line connecting AC, we are looking for the line that is perpendicular and that cuts this exactly into halves. So perpendicular bisector of AC. 3 mark question. Usually these are actually 4 mark questions, but I think it is possibly because we already have the midpoint here. So if this is a boundary point, we already have the midpoint here, so maybe that's where one of the marks comes from. Okay, so let's go ahead and work this out. Find the equation of the perpendicular bisector of AC. I'm going to go down here actually and write this out because potentially it could take up a bit of space. So here's B, and let's write down the coordinate points of A and the coordinate points of C. I'm going to have to look back at what they were. 0, 3, and 8, 13. 0, 3, and 8, 13. Alright, if we didn't know the midpoint, we could find the midpoint, MAB. MAB is equal to the average of the x values, so this is x1, y1, x2, y2. This would be 0 plus 8 over 2, and the average of the y values, 3 plus 13 over 2. In this case, the midpoint would be, once again, 8 over 2, 4, and then 16 over 2, 8. There's our midpoint. So we've got a point on the line. Now we need to find the slope. We can find the slope or the gradient of AC, and then we know that this is going to be perpendicular, the perpendicular bisector. So we can use the negative reciprocal. So if we want to find the slope of the perpendicular bisector, let's first find the slope of AC. Alright. So, actually I shouldn't call this M, because potentially that's our slope. So let's call it midpoint. Midpoint of AB. And now let's find M of AB, that is to say the slope. And we have y2 minus y1 over x2 minus x1. This is our slope, and it's given to you in the formula booklet as well. Might not be a bad idea to label these if you're unsure. It might help you structure things. So 13 minus 3 over 8 minus 0. And this is going to be 10 over 8 or 5 over 4. Okay, so we know that M, or MAB, is equal to 5 over 4. If we're looking for M perpendicular, we know what we're going to do is we're going to switch the top and the bottom, or take the reciprocal, 4 over 5, and then multiply it by a negative. So that would be our perpendicular. We know what MAB is, we're looking for the perpendicular to this line. Switch the top and the bottom, multiply by a negative, or take the negative reciprocal. Alright, good. So we've got all the gradients we need. So we have y is equal to mx plus b. We know that m of this perpendicular bisector is negative 4 over 5. And we also know that it goes through the point 4, 8. So we've got a point on the line. We have an x value and a y value. Let's substitute those in. 8 is equal to negative 4 over 5. X is equal to 4 plus b. And you can end solve this, to be honest. It's not an insignificant amount of algebra, and you might actually save your time, or save some time. Let's actually, I'll work it out in the back end, but you might want to end solve, to be honest. Negative 4 times 4 divided by 5. Answer, alright, so we get an answer of b is equal to 4.8, or if we wanted to, as a fraction, this is b is equal to 24 over 5. Okay. Alright, that's good. It's kind of clumsy to mix fractions and decimals, so maybe we can write this out as y is equal to negative 4 over 5 x plus 24 over 5. If you work this out yourself and you got negative 0.8x plus 4.8, it's all the same. And the IB would actually be just as happy with either one, by and large. Okay, quite a fair bit of work for a 3-mark question, but there it is. Perpendicular bisector of AC. Alright, let's go on. An additional farmhouse D, 6.5, so now we're in diagram 2. An additional farmhouse D at point 6.5 is built on the land. The Voronoi diagram has been redrawn to show the new boundaries. The coordinates of the vertices of these boundaries are indicated on diagram 2. Okay. A wind turbine is to be built at one of the vertices. Okay, the vertices are the corner points. So if we're talking about vertices, we're talking about these points, the points where the boundary lines meet. The wind turbine should be as far from the nearest farmhouse as possible. So this is what's called like the toxic waste dump problem. The wind turbine should be as far from the nearest farmhouse as possible. By calculating appropriate distances, find the location of the wind turbine. This is plural, which is kind of interesting. And then hence write down the distance of the wind turbine to the nearest farmhouse. 4-mark question, not too bad, I don't think. So let's go ahead. We know that the wind turbine is going to be at one of these locations, and the gist of the toxic waste dump problem is that the idea is that these wind turbines make noise, and we want to put it as far away as possible from the farmhouses. And so, if we have an equal distance, essentially, it looks like we can exclude one as possible, one right away. This value of a, for example, actually let me do it the other way. So this is where one turbine could be. And this, just by inspection, looks like something we could exclude, because this distance right here is shorter than this distance here, for example, just by inspection. But the question is, let me actually use some different colors. Oh no. Whoops. So if we're looking at this pink line or this red line, the question is which one is the greatest distance? So the red line signifies the distance between this farmhouse B and a potential turbine. And we also know that this is actually going to be equivalent from this as well. Let me just give a conceptual kind of explanation of the toxic waste dump problem. So all of these points, if we sweep out a circle, then there is the possibility that we want this turbine to be as far away as possible. And remember, the boundary lines are the equal distance, an equal distance to each of these places. So if we go back to this one right here and we sweep out a circle, we're asking ourselves, okay, which one of these is, let's say, the furthest away? Which one of these has the largest radius? Because each of these points are going to be, let's say, the boundary lines themselves will represent, I'm sorry, I'm just kind of mumbling through this. The boundary lines themselves will be equidistant. So if we're looking at point, this is now very messy. If we're looking at point D right here and point B, this is equivalent, this is equivalent, this is equivalent, and so on. The boundary lines represent an equal distance between two farmhouses. And then there's one point where they meet, and that's the edge of a boundary line. And this is the farthest essentially that we can get, where we're still an equal distance away from both. And same here, we're an equal distance away from both at this point and at this point, or rather at this point as well. So which one is going to be the largest? It is going to be the one with the circle, essentially, that has the largest radius. To simplify that even further, I suppose, what we can do is simply find the values where that are the furthest away. So we can take away this point just by looking at it. It seems like it's pretty close to A. So we're really just comparing this point right here, and let's choose any other point. Let's choose this point right here. What we can even do is let's choose these 2 points. I think it'll be good. Okay, so 2 different things we can do. We can use the distance formula, but the distance formula is essentially the Pythagorean theorem. So let's actually just use the Pythagorean theorem. Here we go. So if we're at 6 and we travel to 11, we know we're going to have a base of 5. And similarly, if we're at 5 and we go up to 8, we're going to have a, what can we say, a height of this right angle triangle of 3. So by the Pythagorean theorem, we know that 5 squared plus 3 squared is equal to, let's call this x, is equal to x squared. Then we can work that out. 25 plus 9 is going to be 34 is equal to x squared. We can end solve this, and x itself, you can leave this itself as root 34. Similarly here, let's write this out using the Pythagorean theorem. Here we go. So, this isn't nice. This isn't nice. So this is kind of finicky. Okay. So we know 1 is equal to root 34. Okay, so that's why it's a 4-mark question. If we're going from 9/11 to 6, what are we traveling? Well, this itself would represent 6 minus 9/11. And then we could square that, but I guess we could. And if we're at 5, for example, in our y value, and we go up to 1/16 over 11, then we can also represent this as 116/11 minus 5. And potentially we could put this into a calculator and write this out as a decimal, and that would be okay. Actually, that's exactly what I'm going to do. 6 minus 9/11, square that value. This is roughly equal to geez Louise, 3249 over 1. Okay. Essentially, it's just messy decimals, and it's us using the distance formula. So if we go all the way, and here's our distance between 2 points, x1 minus x2 squared plus y1 minus y2 squared, and then take the square root of all that. Okay, there's no getting around these kind of messy decimals. So here it is. Let's use the distance formula. Distance is equal to y1 minus y2. So if this is x1, y1, this is x2, y2. Alright, we have, just as it says here, 6 minus 9 over 11 squared plus 116 over 11 minus 5 squared. And let's see what we can do. 6 minus 9 over 11, square that value, plus 116 over 11, just working this out on the back end, minus 5, then we'll square that, and then let's take the square root of all of that business, and then it tells us that D is equal to 7.589, or just 0.759. So we have 1 as a messy decimal and 1 as a rather clean root. Let's convert this to a decimal, and this itself is equal to 583. So comparing these, this is the one that would be furthest away, and it suggests that we should build our turbine right at this location, right here. Wind turbines should be as far from the nearest farmhouse as possible. By calculating appropriate distances, find the location of the wind turbine. So essentially, just write out a distance formula just like this, or for example, if the numbers are clean, you can use Pythagorean theorem and construct triangles. By finding the appropriate distances, find the location of the wind turbine. The wind turbine should be at 9 over 11 and 116 over 11. That's where it should be. And write down the distance of the wind turbine to the nearest farmhouse. We found out that the distance was 7.59. Alright, so that one took quite a while. Sorry for the lengthy explanation for the Voronoi diagram. Little clumsy, I suppose. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.